In the previous video, you guys understood about what is a matrix and what is the order of a matrix, all these things, correct? Now let's try to understand what are the types of matrices we have, okay? And we'll discuss about these things in detail. All right. Now the first type of a matrix is what we call as a column matrix. A column matrix. Now a column matrix is that matrix where you have n number of rows but only one column. Okay, again I'll repeat, you have n number of rows but only one column. In the sense, you can say that column matrix C is equal to, you can have n number of rows. So say 1, 2, 3, n number, or say m, because generally rows are represented by m, right? But if you look at it, there are m rows but only one column, right? So this can be written as m cross 1. M cross 1, correct? The next type of matrix is what we call as row matrix. A row matrix. Now in a row matrix, it's the opposite. Opposite in the sense, very similar to column matrix but just ulta of it. Here, you're going to have one row but n number of columns. Okay, that's what we mean by a row matrix. In the sense, here you can say that R is equal to, say this 1, 2, 3, so on and so forth till n number of columns. The order becomes 1 cross n. Okay, so this is the value, or this is the matrix what we call as a row matrix. The next one is a square matrix. It's a square matrix. Now a square matrix, guys, it's in the name only, square matrix. What do you think it is? The row and column should be the same, correct? So that means here a square matrix, so A, something like A, B, C, D. So it's a 2 cross 2 matrix, correct? Now in general what we say is that for a square matrix, we say that A is equal to A, I, J, where I is equal to J. Okay, I is equal to J. In the sense what? The number of rows and number of columns should be the same. That's why we write I is equal to J. So, or in other words, you can also write in another way. That is, you have matrix A of the order m cross m. Same thing, m cross m. Number of rows is equal to number of columns. So, m cross m. This is also another way of explaining that it is a square matrix. Alright. Next look at the next type of matrix. We'll discuss about the next type of matrix now. The next one is a diagonal matrix. Okay. So next one is diagonal matrix. Now this matrix, diagonal matrix, is a square matrix. First thing, it is a square matrix. Okay. And then in a matrix, you have two very important things, what we call as the diagonal of a matrix. Okay. Now first type of a diagonal is what we call as a principal diagonal. Another one is called as a transverse diagonal. Okay, let's try to understand what is what. Let's take a 3 cross 3. 3 cross 3 is a square matrix, correct? Now, let's take a 3 cross 3 matrix. Say A is equal to, say 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, here, the principal diagonal is this value. This is the principal diagonal value. Okay, from left top corner to bottom right corner. That is what we call as the principal diagonal. And the other one, that is 3, 5, 7, is the transverse diagonal. Okay. So this value 3, 5, 7. This is what we call as the transverse diagonal. And the red one, this one is what we call as the principal diagonal. Alright. Principal diagonal. Now, diagonal matrix. So, a diagonal matrix is a square matrix where the principal diagonal elements are non-zero and unequal, but the rest of the elements are zero. In the sense, well, example I'll give you. So, you have a diagonal matrix, say B is equal to 1, 0, 0, 0, minus 5, 0, 0, 0, 121. See? It's a principal diagonal. The elements of principal diagonal are there and which are non-equal. They're unequal to each other. And the rest of the elements are 0. Correct? So, we can write the general form of a diagonal matrix like this one. So, matrix A is equal to Aij, first and foremost, I value, or you can say M cross M. That means it's a square matrix. And you have Aij where I is not equal to j. That means the position of the element, first row, second element, first row, third element, something like this. I is not equal to j. I is not equal to j. This value is equal to 0. In the sense, something like, look at the matrix what is given here. If I take this value, it's a 0. It is first row, second element. In the sense, first row, second column. Correct? So, I value is 1. So, for this value, I'm looking at this particular value. So, for this one, I value is 1, j value is 2. Now, I is not equal to j, but Aij, the element value is 0. Correct? That is the meaning of Aij, where I is not equal to j, this value is 0. So, this is true in every case. Look at it. Assume that we are looking at, okay, let's take this value. So, if you take this value, third row, second column. So, I value is 3 and j value is 2. I is not equal to j, but Aij is what? 0. Now, this is a diagonal matrix. Okay, let's look at the next type of matrix now. Scalar matrix. Okay, so this is a scalar matrix. See, scalar matrix, first thing, it's a diagonal matrix where the principal diagonal elements are the same. Okay, first thing, you need to understand it's a diagonal matrix. So, the rest of the elements are 0 except the principal diagonal. But the principal diagonal elements are the same. That is what we call as a scalar matrix. Okay. Example we can write, very simple example, say A is equal to 5 0 0 0 5 0 0 0 5. See, this is a scalar matrix. Beautiful example for scalar matrix. So, in general, how we have to write? You have matrix A is equal to Aij. This is M cross M. That means you are telling that it's a square matrix in such a way that Aij, here I is not equal to j, this Aij is equal to 0, this is first, and Aij is the value. If I is equal to j, that means it's the diagonal, principal diagonal. So, all the elements are equal, correct? Did you all understand? Aij, I is equal to j, the values are equal here. Whatever might be the number, but the number on the principal diagonal should be the same. This is what we call as a scalar matrix. Okay, the next type of matrix what you have, a very important one, identity matrix. Identity matrix. Now you are going to use this identity matrix a lot in this and the next chapter. So pay attention. See, an identity matrix is a scalar matrix where the value of the scalar matrix is 1. In the sense, an identity matrix is always represented by I. So 1 0 0 0 1 0 0 0 1. So it's a scalar. First thing, it's a scalar matrix. Second point is the value on the principal diagonal is 1, whatever it might be. Okay. So in this case, in an identity matrix, suppose if you have a 2 cross 2 matrix, then we represent it as I2, which is nothing but 1 0 0 1. The one what you are seeing here, the 3 cross 3 matrix, this is represented as I3. I3. Okay, I3, this is I2. Now the last type of matrix is what we call as null matrix or zero matrix. Okay, null or zero matrix. See, this is a matrix whose every element is 0. Every element. Irrespective of what the position of the element is, if every element is 0, then it is what we call as a zero matrix or null matrix. So generally it's represented by O, 0. So this is equal to Aij, which is equal to 0, M cross N. Take any value. If every element of the matrix is 0, then we call that as a null matrix or zero matrix. So understand these are the types of matrices what you have. So in the next video, we'll solve a couple of problems in understanding how do we frame a matrix and how the equal to and everything, equality of matrices are going to work. Okay, we'll discuss that in the next video.